Welcome back, students. In this video we are going to discuss about queues using linked list, implementation of queues using linked list. So linked list, we all know linked list looks like this. It has nodes. So this node is pointing to this node is storing address of the next node. If there is no next node, this node will be null, right? And this is the first node of the linked list, so we will have a pointer pointing to this node called as first pointer. And here we have data 10, 20, 30. So this is called as linked list node. This is a node of the linked list, and this node can be created by using a struct node. Inside that node we have two things. First is this data part, so int data, and the next is this is a pointer which is pointing to the another node. Node is the type of this node. Type of this node is struct node, so that's why the type of this pointer is struct node star p, or star next will take, right? Struct node star next. So this is the structure which we use to create such kind of nodes, right? And this is a linked list, we know, right? Now what is queue using linked list? Now in this linked list there are some nodes. The nodes are let's say, for example, if I talk about this node, let's say this node has come first in this, or this node is inserted first in this linked list, and this node is inserted at last. That means this is the latest node by time spent, or by time of insertion, and this is the node which has come in first, right, or inserted first. So the node, as we know in queue, we have two ends, front end and rear end. Front end will be an end which is from where the elements will be removed or dequeued, or they will be served. That is front end. And rear end, so in queue, front end is an end where the elements from that end, the elements will be removed from the queue, and rear end, the new elements join the queue, right? So let us say we have two pointers here. One is called as front and other one is called as rear. Like we had front and rear variables in queue implementation using arrays. Here we will have two pointers. These are now actual pointers. These are pointers now, right? So let me, so this is front pointer. It will be pointing to the front node, or the node which has come in first in the queue, or inserted first in the queue. And this is, now here the queue is nothing but a linked list. The queue is nothing but a linked list. It's like a normal linked list, right, which we have, right? Only thing is I will not have this first pointer here now. I will not have this first pointer. So this is a linked list. It's exactly a linked list which we know, and the first node of the linked list is pointed by first pointer. It's a pointer. First is now a pointer. It's not a integer variable. In queue implementation using arrays, f was the integer variable which was storing the array index, right? And r also was storing the array index. So they were integer variables. Now here they are actual pointers to structure. So first pointer, or f pointer, will point to the oldest node in the queue. Oldest, I mean, by oldest I mean the by the time of insertion of node in the queue. And rear pointer will point to the latest node of the linked list. That means the node which has recently inserted, or inserted at the last, right? These are the two pointers, right? Now this is called as queue. This is our queue, right, where the actual nodes are the nodes storing data, and this front end, rear pointer. This complete structure is called as queue here. This complete structure is called as queue. Queue using linked list. Queue implementation using linked list. Now what I don't want this front and rear to be separate, or I want them to combine in a single variable. I want to combine this front and rear. I don't want them separate, right? Like f is individual, r is individual. I don't want that. What I want is, I'll show you what I want. I want that f and r should be in a single variable, that this variable, and this variable I will call as q. Right here, f, this is f, and this is r, f and r, f and r. So f is a pointer, r is also a pointer, and these two are put inside a variable called as q. And this variable can be created by using abstract data type. Right, this is an abstract data type. I can create this variable by using structure. So f is a pointer, r is a pointer. Both are node type pointers, struct node type pointers. F is struct node type pointer, r is also struct node type pointer. So I am putting those inside a single variable called as q, and that q variable is nothing but the q which we are talking about. It's a q. And when there are elements in the queue, when there are nodes in the queue, f will point to the oldest node, right? Let's say we have one more node here, and there is no next node, so right, and r will point to this, like this, and f will point to this, 10, 20, 30. So our queue is actually this, this variable q, in which I have f and rear, and f is pointing to the oldest node by time of insertion in the queue, and rear is pointing to the latest or youngest node by time of insertion in the queue. So this is my queue, right? So you see here there are two structures here. If you see, the first is this node structure, that is this one, right? And the second one is this structure, right? Now how can I create this structure, right? So this struct q, and what is there inside this? I have two variables, f and r, and both are pointers of this struct node type. So struct node star f comma star r. That's it. So, and by using this structure I can create such variables. Right? So now we'll see the different scenarios inside Q using linked list. So we'll see that in the next video. So see you there. Thank you.